Good evening, good day all. This is Anirban. Today I intend to discuss about the various ways of processing images in a REST API endpoint. So I found from my experience that this aspect has caused some confusions in different projects. Sometimes we have a API and the project is designed in such a way that the images have to be uploaded to some cloud storage like the Azure Blob or the AWS S3, and the images can only be processed from there. But that's not a good way. As the days goes on, the requirements are coming more towards real-time processing of images, and end users or consumers are interested to send the image directly to the endpoint and get a processed image, be it a inference generated from the image, be it a pre-processing done on the image, whatever it is, they want the processing to be directly on a real-time endpoint. And so it is very important that we accept the image on the endpoint and then use the various libraries, be it the OpenCV, the scikit image, or the pillow, and we basically do all the stuff that we do, like the various kinds of pre-processing to enhance the image quality, take it through an inference process, and finally the main goal here is how we can write this API, how we can dockerize it in a container. And once we are able to test it in a dockerized container, uh, this is immensely valuable because, as we know, what a Docker container does is it isolates all the dependencies. And here there could be a lot of problems. We have faced good amount of problems due to conflicting versions when using the OpenCV and various other libraries. Sometimes we can have difficult problems, and we need to spend many hours debugging this version conflicts and all those things. But Docker can eliminate all of this, and using Docker, one can quickly deploy this API on a cloud portal, be it the Azure, be it the AWS. It's uniformly accepted everywhere. So that is what I wanted to discuss. In fact, in one of the projects that I did in the past, when we came in, the design was done by another vendor, and they did it in such a way that the images have to be first uploaded to a cloud data store, and from there it will read the images and generate the inference using some kind of deep learning algorithm. But our users, the end users, the consumers who are going to use the application, they came back and said, no, we want to send a image to your API. And one of the best formats that I've seen is the base 64 encoded format. This In this format, the image just becomes a string, a compact string, and this can easily be sent to the API quickly with a very fast response time. And FastAPI is well suited for this because of its asynchronous capabilities, because the fast response time. So I just want to show how we can accept an image in different ways in a fast API endpoint, and then convert this image into different formats which are suitable for OpenCV, suitable for Pillow, so that we can do all the pre-processing, let's say the resizing, let's say the histogram equalization and all that, and then we can send back the image, pre-processed image, again as a base 64 encoded string to the consumer. To start with, I will share the folder structure that I have. So this is my Python project demo. So I have the app folder, I have the utils folder. So in the app folder, I have the main.py, which is my REST API endpoint. So in the fast API, this is how we write endpoint layer, where we have the actual REST endpoints, and we can have our business logic or functionalities inside the utils, where we do the processing of the images or whatever data we have. So sometimes it's also beneficial to have a non-functional endpoint, something like a hello world, which basically shows that if we hit this base URL, we are getting this message. That means this API is up and running. So that's what this uh, API is. It's a GET API, and it runs at the root, and all it does is returns a message saying hello world. So the first API, real API that we have here is this process encoded image. So when we do this process encoded image, we basically, the way we do it in FastAPI is we give a response model here, which is my pydantic data model, which accepts output in a Python object and converts it to a JSON object while sending the response. So these data models are defined in the data models.py. So I have a input data model. All this accepts is an image, which is a string object. So in the JSON, I'll have an image, right? A key which will have the string object, which is the base64 encoded string for that image. That's what it accepts. And the output is the processed image, again a string object, maybe a status message, success or failure, and error message if any. So that's my output object, that's my input object. They both basically extend from the pydantic base model, as we can see here. And this is seamless in FastAPI. The conversion from this object to the JSON is seamless if we use the pydantic data model. So that's why this is one of the best practices to use this, right? So now here's my input in this image API. The input is the data models.input, which I just now showed. I also have a query string here, input format. Now this is a optional query string. I may or may not provide it. So the way it is done in FastAPI is it is specified like this. It is a union of string or none. And what we are doing here is we are saying if the input format is none, we basically take a default format, which is a PNG. In this case, we are accepting PNG and JPEG format. So we are saying if the input format is not PNG and not JPEG, then we are basically saying that it's a failure. Input format can be JPEG and PNG only, and we return the response. Now, if this input format is correct, we come here and we say image utils dot base64 string to pil image input dot image and the input format. So we pass the image string that we got from the input object, which is this image object, a string object, which is the base64 encoded string, and we pass it to this function. We also pass the input format because who knows, the user may be using a PNG image or a JPEG image, so it's good to have that input. So what this base64 to PIL images does is basically uses the base64 library in Python, and uh, basically it decodes the string and it writes it into a temporary file. Base64 image bytes, base64.encode UTF-8, base64 bytes is equal to base64.b64 decode. So here we use the b64 decode function, passing it the bytes we have, and this bytes object we use to create a pillow image object, and we just then save that image. That's what it is. So once this image is saved, we have this image now with us, and then from then on we can read this image and do the various pre-processing functions. So how do we do that? So this is in the image utils. Now this is something of a convention which is always used, that my utility programs which does specialized functions, they should not all be in the services layer, they should be in their own packages. So the app package is where I have my data models, where I have my REST endpoints. The utils package is where I have my image utils. I could have some other utils if I have some other complex functions, let's say machine learning utils or whatever. In this case, I'm just doing a pre-processing of the image. So what this method does is it does pre-processing on the image, grayscaling, for example, histogram equalization, resizing, etc. And one can vary this. So the first thing it does is it now I have the image as a .png or a .jpeg file. So first thing I do is I read the image in OpenCV using cv2.imread. I find out the height, width, and the channels of the image. I find out the aspect ratio, and I fix a target width because I want to resize image. When in the real life scenario, when we get images, as I said in one of my earlier tutorials, it never comes like uniformly sized 32 by 32 images. It will come in varied formats. So one of the first things, I mean, in varied sizes, one of the first things that helps a lot is if we resize the images to uniform size. So that's what we are doing, maintaining the aspect ratio. So we basically uh, take a size of 1000 pixels wide, and we get the target height by using the aspect ratio, and then getting the corresponding target height. So once I have the target width and the target height, I basically now have, now this is important, I have the image in the pillow format, right? Because in the OpenCV format, I'm sorry, I read it in the OpenCV format using cv2.imread. So now since I'm going to use a pillow image operation to resize, right? Because I'm going to use the Langsource filter when downsizing the image, which is one of the best. I basically have to convert the OpenCV image into a pillow image format. So the so that's what is being done here. This image PIL format is image.from array of the image object from OpenCV. The image resized is now I do the resizing of the image using the pillow image object that I have, as I explained some other day, that if my height is or the width is less than the target, I do a zero padding, right? And if it's more, then I use a Langsource filter to basically downsize that image, right? This has always worked well in deep learning models when we resize the image in this way. That's what we have found in some of our projects. So once we do this, now I have resized the image. Now, now the resized image is what I'm storing in a temporary store so that it may be needed later on for some operations, because this is the original image which I've resized. And now to do some operations, it could be a deep learning image classification algorithm. It could be that I want to OCR from that image. It sometimes happens that we want to convert the image to grayscale. So I do a grayscaling of that image using OpenCV, right? And here's one more step before that. We create the OpenCV format of the image from the pillow image using the np.as array. So this is what is giving me the OpenCV format of the image, which I can write using cv2.imwrite. So basically the pillow uses a two-dimensional array to represent the image, whereas in OpenCV it is the channel information is also there. I mean, that's what my understanding is. So now this the pillow basically uses a simple array format, right? So now once we have got it in the OpenCV format from the pillow, we can now use the grayscale using the cv2.color bgr to gray, and then we can do whatever pre-processing we want. I'm just showing one example, which is the adaptive histogram equalization. And once I do that, I can basically write this image as a temporary file, and this will get generated inside the Docker container once I Dockerize it. Right now it will show up here when I run the code, but finally it will basically get generated inside the Docker container. So I'm writing the file and returning the file name from this. So once I have pre-processed my image, I know here that what is the file name where it has been written after pre-processing. Now I have to return back this pre-processed image to the consumer. So there I do the opposite process. I do the base64 encoding of this image. I read this image file, do a base64 encoding, set it in the output object, and output dot processed image equal to base64 str. And I think there is a small mistake here. Output dot status should be success. Okay, by default it is success. So if I don't set it, it will always be success. So this is fine, and I return the output. Right. So once we write this code in this way, the way to run it is basically we just use the command evcon app.main colon app. So this is finally my UVCon run here, app.main colon app, and a minus minus reload, because if I make any changes, it will reload the API instantly. So I'm sorry, once I run this, I was running the Docker, so it's saying the address is in use. So my Docker is now stopped. I'll come to Docker later. Okay. So how do I run this is I give this command evcon app.main colon app minus minus. Why app.main? Because app is the package and main is the program within that. So I run this. So it says running on 187.0.0.1 8000. And how do I verify this? I basically go to the Swagger interface. So I go to 187.0.0.1 8000 slash docs. This is a standardized Swagger interface which gives me a chance to see my API at a glance, publish it to the consumers, and they can test it out from there. So this is one of the best practices, Swagger Open API interface. So I can see the get method here, and if I want to try out any of those methods, there are three methods. One is this process encoded image, which we just now saw. There's another one where it accepts the image as a file, which I'll show it, and the other is just the get. So if we want to try it out, we just say try it out, execute, and we see that it's returning the message hello world with a code of 2000. So my API is up and running. That's the first test. Now when I want to run the encoded image, here I basically say try it out. My image string is what it's expecting, and this input format is a query string which I can give as JPEG. Default is PNG, and I can just download an image from the internet. Let's say I can just search some images. I can take any image. Let's say I take any image, doesn't matter. So I can put it in my project. My project name is this one. So it should appear here. This is where my image is. And what I can do is, now I need to pass the base 64 encoded version of this image to this API. Now this works very good across technology stacks. So we have seen .NET UI, .NET Best UI, they are also able to use the base 64 encoded format and send it to our API, which is written in Python and FastAPI. So for that, I take help of this image encode.py, which takes the image and basically writes the base64 encoded string into a temp.txt. So I just say Python image encode.py minus minus image, if my image dot jpg. I hope to see, yeah, I see a temp.txt file here. So it has a big string here. So I do the entire thing, copy it, and if I put it here now in this string, it should work basically. So this is the base 64 encoded string, which can be used to send the image directly to the endpoint. Say execute, I get the processed image back. Now, how do I know whether it has processed properly, it has done anything? I can take this processed image back and I can decode it also. Status is success. So I can take this image. It's difficult to, bit difficult to do it like this. This is not the best practice to copy it like this. I'll show a client code also, but right now I'm showing this. So I take this string and I put it in my decode image decode.py. I just put this inside this base 64 string. So I have this image decode.py, it will write it into a temp1.jpg. So I just say Python image decode.py. Everything goes well, I should see a temp1.jpg. So this is my enhanced image, which is using some techniques like adaptive histogram equalization or whatever it may be. It's not making much of a difference here. Looks like the same image, but that's fine. I mean, that's not the intent to show here. I mean, it could be any number of image pre-processing operations we can use over here, but this is the image which I got after doing the image pre-processing in my application. So this was the image. This was the image, and as we can see, the resizing has occurred because I can see that it has created this zero padding outside the image because that's what I had specified my target width and height, right? So that is how this base 64 encoding works. It accepts a string as a base 64 encoded string as an input, and it can output that. Now, some users, if they want, they can use a file object as an input also. So I have another endpoint here within the same code, which accepts the image as a file object, so as a multi-part or form data, and basically returns the same base 64 encoded image. So I can try it out. I can say choose in, when I say try it out, here it is not requesting a JSON, it's saying please upload your image file. So whatever image file we want, we can upload it. So for example, I go to my doc home, I go to the same project from where I was doing, and I upload this particular image, and I say execute. So what it does is gives me a pre-processed image in the same way. So how that is done, I'll show next. So in the main.py, we have another API, which is this endpoint, which accepts a file object. So in this case, everything remains the same, but here it's a file, upload file equal to file. So that's how FastAPI accepts a file object. Now once we get this file up, the way object, the way we read it is we say contents equal to await file dot read, and then we basically create a array, numpy array using numpy from these contents, right? And this numpy array is now used to pre-process my image in this pre-process image function. So what this does is it first converts image to OpenCV format using something called a cv2.im decode. We pass the numpy array using cv2.im decode, and we say that retain the color cv2.im read color. So we get the colored image, and this image now we can grayscale it, we can resize it using pillow, we can again convert it back to OpenCV, and I mean we can do everything in OpenCV also. Someone may say why we are converting into pillow, why not everything in OpenCV? That's also possible. It's basically a person's convenience, the way he uses these pre-processing algorithms. It could be in scikit image, it could be in OpenCV, it could be in pillow. There are some good and advantages and disadvantages in each of these libraries. So all I'm showing is how it can be converted between the various formats. Here I'm converting the cv2 image format to a pillow image format using image.from array, and then once I resize it, I convert the image back to OpenCV format using np.as array. And then using the OpenCV, I can do adaptive histogram equalization, and I can use the OpenCV to write the image as a temporary in a temporary file. And from then on, basically, it's the same process. Once I've written the image into a temporary file, I just encode the image in a base64 string, set it in my output object, and I say return the output. So I get the output with a output JSON with a base64 encoded string. Now this is all fine, but this is not going to be also very modular and deployable if we just do it on my local machine. So it has to be deployed on a cloud portal to deploy this API in an enterprise-wide scenario. And how do we do that? So one of the first steps to do that is basically create a Docker file. And in this Docker file, we can start from a particular Docker base image. In this case, we are saying use the Python 3.9 Slim from the Docker repository. We run the apt get update. There are a few libraries which OpenCV requires, and we need to install this. This is again, we learn by practice, may not be given anywhere in any book. I haven't found at least, but these are some of the libraries. If we don't install as a prerequisite, the OpenCV doesn't work properly, right? So, and all our requirements, all our basically packages that we require, the best practice is to put it in a requirements.txt. So that is what we are giving here. Use the FastAPI, Pydantic, UVCon, Pillow, OpenCV, Contrib Python, all those things, and also the base64, which does this encoding and decoding, scikit image, scipy, whatever we need, we can give it here, and we can say copy the requirements file into the Docker folder. My work dir in the Docker folder is /code, and we basically say run pip install of this requirements.txt. And then finally, we basically copy the code that we have in the app folder and in the utils folder into uh, code/app and code/utils, maintaining this package structure. Say expose 8000, and finally we run this uvcon command. So how I build the Docker is basically very simple. Once I have Docker installed using pip install Docker, I can just build this Docker image here. Before that, I wanted to show also the client program, how to invoke this API. I showed it from the Swagger interface. The client program is like this. So if I want to pass an image, I use the URL, and on this URL, I post the image uh, with a JSON object. So this is the client program, very simple. If I pass the image object, image path in the argument, basically I use the same code to encode this image, and I create a JSON object, image JSON, which has the one object, which is the image, which is what we get in the Swagger interface. We have to create this JSON. So the Swagger interface shows this request body, if we remember, as the input. The image is the only thing that we have. So we create this JSON, and basically we say requests.post URL equal to URL JSON equal to this JSON that we created. If there is a security header, we can give it as a header over here. Right now it's a simple API. I'm not using security. So this image is now sent to the API, and the encoded image is obtained in the response JSON, and we can basically uh, write this back as an image by using the opposite process, which is the decode process, using this base64 to PIL image function. So how I can do it is I can use this program to basically run it. So I pass the image parameter. So my image was myimage.jpg. Myimage.jpg. It is the same folder, so I need not give a path. Request completed very quickly, and basically I should see a output.jpg somewhere here. If it's done, yes, I see the output.jpg. I can delete it off, again run it. See, it's very fast. The output.jpg it has written. So that is how the client program works, and how the Docker container is to be run is here. I've given the command in the README file of this repository, which is there in the GitHub. So I take this Docker command and I put it here, paste. My Docker gets built. It's very quick now because I have already built it once, so it keeps it in the basically in the cache, and uses that. It's using cache. If not, it will install all these libraries. So it's a best practice in the requirements.txt. We we have to put the libraries in a certain order, and in the deploy container.docker file, they also should come in a certain order. The most intensive installation should go first, like that it should come, right? So it is done, and once it is done, I basically go and run this Docker image. Okay, it's saying this is already in use, because that's true. Look, I'm already running this, so I need to stop this server here. Docker is not getting the port because it's already in use. Okay, still giving the same. Should not. Okay, so now it's running. We can see the process status. Yes, it is running. It's running at 0.0008000, and that's what we'll now to check how it's running on the Docker. If it's running successfully or not, we can go, instead of using the local host, we can give 0.0008000 slash docs. Same Swagger interface should be there, but now it's running on the Docker. I gave one extra zero, I believe. Yeah, so it's there. So I can see it's running on the Docker now. I can check the hello world interface. And one last thing is, how do we write unit tests on the API layer? So here I have written unit test on the API layer. The main important thing here is I use the test client from FastAPI, FastAPI.test client, and I pass the app object from my app.main into this test client. And once I do that, I basically use the client.get slash to check this whichever URL I need. In this case, I'm checking the root URL where my hello world message is going to come, and I'm asserting that. So if I say PyTest here, so if I say pi test 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 here, so if I say pi it one passed in 0.26 second. If I make it different string, definitely it's going to fail. It's now failing. It's saying that the message is hello world ABC, but the assertion error, the message should have been hello world. So this is how the unit test is run on the API layer, and we can write such unit tests for all the endpoints that we have to make sure that these tests don't fail before the final deployment on the Docker. So with that, I'd like to end today. Just wanted to show the various operations, image operations that can be done within a fast API endpoint, how the image can be sent as a file object, quickly uploading the image, testing it, or for a enterprise consumer, how the image can be accepted as a base64 encoded string and returned back as a processed image in a base64 format. Python libraries have made it very user friendly to use these libraries. Initially, we used to get like quite nervous. I remember, how do we send a base64 string? How do we encode it? But later we just found out it's just a few lines of code, and this really works well in enterprise scenario, because I've seen different tech stacks can convert the image very conveniently into base64 encoded format and send the image to a endpoint rather than uploading into some cloud server and sending that URL, which requires a lot of other effort, right? So this is one of the most direct ways of invoking API with the image, and that's what I wanted to show today. Thank you. Thanks all.